All right, in this video we're going to talk about Unit 1 Objective 3 and Unit 1 Objective 4, Riemann sums and average value. So we're going to start with the definition. So just like when we were estimating the slope of a tangent line using the average rate of change, we're going to estimate the area under a curve. And in calculus, we're going to call the area under the curve the integral. So we're going to estimate the integral denoted with this, and it's kind of hard to see, but it's on your paper already. It's a little s thing, a to b of f of x dx, and I'll explain how we read that in a second. We're going to be able to estimate this area under the curve two different ways. The first way that we're going to talk about in this video is to create a finite amount of rectangles under the curve, and then we're going to add all these areas together. Using the integrals, or I'm sorry, the rectangles is called the Riemann sum. So going back to this little notation thing here, this little s is going to stand for the sum of a bunch of rectangles. So that's where the sum comes in. A to b is just going to be where you start looking at your area and when you stop looking at your area. So if we have like a function that looks like this, and I want to find the area under the curve from a to b, so if I want to find this area here, that's what the a and b stand for. F of x is the function, and dx means the change in x or with respect to x. And I'll show you how these things kind of fit into the rectangles on the next slide. So there's going to be three types of Riemann sums, three major types, three that we're going to be talking about. We're going to number these 1, 2, and 3. So this first one here is going to be called a left Riemann sum. Then we have a midpoint Riemann sum for the second one. And we have a right Riemann sum in the number 3 over here. Now, you can probably figure out why these things are called right, left, and midpoint, but if you look, if you look at all of these rectangles here, the left point of each rectangle is touching the function. So that's why this is a left. If you look at the midpoint on the top, on the second one, they're all touching the function, and then likewise over here, the right side is all touching the function. Now going back real quick to this little thing here that we saw on the previous slide, we know that the area of a square is the base times the height. I'm sorry, a rectangle is the base times the height. Well, the height of these functions, or these rectangles here, is going to be however high the function is, right? So if we look at this rectangle here, the height of this rectangle here is just whatever that f of x value is. So this is going to be our height, and then dx is going to be our base, dx meaning the change in the x value. So however far the x value changed from here to here is going to be the base. So this is really, we're adding, remember, sum. We're going to sum up all of the rectangles from A to B, and we're going to have the base times the height. So that's where that little integral sign comes into play with our Riemann sums. So let's look at an example. And we want to estimate the integral from 0 to 3 of f of x with respect to x using a left, right, and midpoint Riemann sum and the sub intervals indicated by the table. You will almost exclusively be given a table when you're asked to find Riemann sums on the AP exam. So let's start with a left Riemann sum. So we'll do the left one in black. So the integral from 0 to 3 of f of x dx is going to approximately be, and now we're just going to start building rectangles. So if we think back to that previous picture we just saw, we would say we're going from one x value to the other x value, and that's one little interval there. So if we think about this here, we can start our rectangle here, and our rectangle is going to end here. So we're going to make a rectangle out of these x and y values. So it's going to start at 0, 0, and it's going to go to 0.5, 1. So the base, the dx of this rectangle is going to be 0.5. And since we're dealing with a left Riemann sum, we want to take the left number out of these two things. So again, if we look back at the picture here, every time we're picking the left variable, the left y value on our rectangles. So the y value is the height, so the height for this first rectangle is 0. Then we're going to look at our next rectangle. It's going to start at 0.5, go to 1, so the base is 0.5, and it's going to go all the way to 1, and we're going to take the left hand of that rectangle. So the height for the second rectangle is the left number, so it's going to be 1. And then we're going to go again from here to here. Again, the base, the change in the x is 0.5. The left hand number is going to give us our height, so that's a 2. And we're going to keep trucking along. We have another base of 0.5. This time the height's going to be 2.5. Move along again. So again, we're going to have 0.5. This time our height is 3.5. And finally, we're going to have a 0.5 and a 4. Now, I mentioned in a previous video that with AP, we do not want to simplify. If we simplify and make a mistake, we are going to lose points. So as far as our answer is concerned, we're finished. We don't want to have to simplify. We don't want to multiply anything out and add everything together. We might make a mistake. So we're going to leave our answer here, and we are going to move on to the next one. One other thing that I do want to note, we have to keep this 1 here. We can't just make this a 0.5 or we're going to lose a point because they want to see us doing the Riemann sum, so they want to see the base times height in everything. So we need to write out 0.5 times 1. We need to write out 0.5 times 0. We can't just leave that empty. All right, so let's look at the midpoint now. This one's going to be a little bit different. So we're still going to say the integral from 0 to 3 of f of x dx is approximately equal to. But this time, we need to have a midpoint. So if we tried to use this first interval here, we wouldn't have a midpoint to choose from. So we actually want to skip over that, and go all the way to 1. So now we can say the base of this first rectangle is going to be 1. And then the height is going to come from the midpoint. So before the height came from the left values, now the height's going to come from the midpoint. So the midpoint between 0 and 1 is 0.5. So the height, its y value, is going to be 1. So 1 times 1 plus, now we're going to go from here, skip one of them, go to the next one. So we're again, from 1 to 2 has a length of 1. The height is going to come from its midpoint, so 1.5's y value is 2.5. And then we have one more to go. Once again, the base of that's going to be 1 because the distance from 2 to 3, the change in x is 1. The height is going to come from the y value of its midpoint. Its midpoint's 2.5, the y value is 4. And once again, we don't want to simplify anything because we might make a mistake and lose points for no reason. And then finish this off with a right Riemann sum. So again, we're going to estimate from 0 to 3 the integral of f of x dx. And we're going to start here. So the change in x, the base is 0.5. But this time the height's going to come from the right-hand side. So the right-hand side of 0 and 0.5 is 0.5, so its y value, the height, is going to be 1. And then if we keep following along, we're going to get 0.5 for a base, because we're going to go from here to here, and we're going to say 2 is its height, plus 0.5 times 2.5, plus 0.5 times 3.5, times, or plus 0.5 times 4, and 0.5 times 5. And once again, we don't want to simplify anything. We want to keep it there. We don't want to lose senseless points. That's the basics for Riemann sums. All right, so we have the meaning we got to talk about. So the meaning of the integral is going to be the total change in the antiderivative. So over the time interval. So the units are going to be found by multiplying the units that were given. So that's the opposite of what we did when we were finding a derivative. Derivative we divided. So opposite of a derivative. So this time we want to multiply. So use a right Riemann sum and the intervals indicated by the table to estimate the integral from from 1 to 5 of f of x dx, and then explain its meaning in the context of the problem. So we have a length, or base rather, of 1, right Riemann sum, height's 4, base here is 1, height's going to be 6, base of 1, height 7, base of 1, height 10. So since this one's pretty easy, let's go ahead and simplify this real quick. 4 and 6 is going to be 10, 27. Now our units, again, we're going to multiply our units that we were given. So we had gallons per hour and hour. So if we have gallons per hour multiplied by hours, which is really like hours over 1, our hours are going to cancel out and we're going to get gallons. So the meaning is going to be the total change in gallons on the interval 1 to 5. So we always want to say that total change in, give our units, give our time interval. So total change in gallons on the interval 1 to 5. Now we have one more thing we got to get to real quick, and then we'll call it quits on this video. So the last thing we need to talk about is going to be average value. So if we divide an integral by the length of the time interval, or if we multiply by 1 over b minus a, we get the average value. So the meaning of the average value is going to be the average y value of what we're given over the time interval. So use your estimate from example 2 to find 1 over 5 minus 1 times the integral from 1 to 5 of f of x dx. Interpret its meaning in terms of, interpret the meaning using the correct units. So we know from the previous example that this piece here was 27 gallons. Now this 1 over 5 minus 1, if you notice, 5 and 1 are time, right? They're measurements of time, 1 hour, 5 hours. So when we multiply this by, I'm going to go ahead and say 1/4, we're really talking about 1 over 4 hours. So this is going to give us 27 over 4 gallons per hour. And if you look back, our units to start with on that previous problem were gallons per hour. So the y value of f of x is gallons per hour. So our meaning would be it's the average gallons per hour on the time interval 1 to 5. So that'll do it for this video. We'll see you in the next one.